So welcome you all in this next class of design of steel structures. And how does this steel came into picture? Let us start from there. Actually earlier iron was basically used as one of the construction material, and also in RCC course you have many times heard steel reinforcement bars. We say there reinforcement bars को हम क्या कहते हैं? Steel reinforcement bars. स्टील बार्स हम वहां किन्हें कह रहे होते हैं? उन लोहे की छड़ों को जो आप मार्केट में या किसी भी कंस्ट्रक्शन साइट पे देखते हैं. So how steel evolved from iron? So basically if we see, steel is an alloy of iron. When carbon in very small quantities is mixed with iron, the steel is obtained. And after addition of carbon, the mechanical properties of iron is significantly changed. And see, at the microscopic level, something very wonderful happened. And if you look in the periodic table, the carbon element and the iron element, the diameter of carbon atom is very less in comparison with the diameter of iron atom. And this carbon atom can be very easily dissolved into the iron atom lattices. So atoms are arranged in particular arrangements in any material. Just like there are different kinds of arrangements of atoms and they are called lattices. And we have studied different kinds of lattices in the 12th class. In any lattice arrangement of atoms, there are some voids available. And these voids are called interstices. And the carbon atom can get dissolved in the interstices of iron lattice. And after getting dissolved in iron lattice, the original lattice of iron gets distorted. अब देखो कोई आयरन की एक लैटिस है जिसमें 8 या 10 या 12 आयरन एटम है और उसके बीच के वॉइड्स में आपने कार्बन एटम को डाल दिया by some arrangement of alloying technique. तो क्या हो जाता है कि क्रिस्टल डिस्टॉर्ट हो जाता है, and due to this when some external force is applied, the further distortion of lattice is avoided. क्योंकि क्या होता है जब प्योर आयरन लैटिस होती है, अगर आप उस पर फोर्स लगाते हैं तो बड़ा ही आसानी से ये स्ट्रेन आ जाता है इसमें. पर जब उसके अंदर कार्बन एटम्स डिसॉल्व्ड होते हैं तब क्या होता है, जब आप एक्सटर्नली फोर्स लगाते हैं then it resists and it doesn't allow to dislocate, and that provides mechanical strength in a steel in comparison to iron. Obviously adding more and more carbon in the lattices of iron increases the distortion of lattice and provides mechanical strength. But however, solubility of more carbon into iron lattices also has some negative impact on some other properties of iron, which is called ductility. अगर बहुत ज्यादा अगर कार्बन एटम को डिसॉल्व करा दे आयरन लैटिस में तो क्या हो जाएगा, द लैटिस विल कंप्लीटली डिस्टॉर्ट एंड गो आउट ऑफ इट्स शेप. एंड इफ वी अप्लाई सम एक्सटर्नल फोर्स इट विल नॉट रिमेन डक्टाइल. एंड व्हाट हैपेंस इफ समथिंग इज नॉट डक्टाइल? इट फेल्स विदाउट गिविंग सफिशिएंट वार्निंग and such a substance is called brittle. See, if you look at the carbon compounds like graphite or coal, it's brittle. So our iron alloy will also not remain any more ductile. It cannot be drawn into a wire. It will turn into a brittle material if we increase the amount of carbon in the iron alloy. So we keep a very minimum amount of carbon in the iron. And the range of carbon content in iron alloy is 0.12% to 0.25%. This is the possible range of carbon content which we allow in steel. So I am not discussing different kinds of alloys of a steel which have different names, because that is also out of syllabus and will take much of our time. So let us discuss what are some more elements which are present in steel also. See, besides useful elements, there are some harmful elements also present in steel, like phosphorus and sulfur, because these two elements eventually form phosphides and sulfides, which are very harmful if we talk of the toughness of the steel. So to reduce that harmful effect of phosphides and sulfides, we add manganese. And when manganese is added to the steel, manganese form manganese sulfide and manganese phosphides, which are less harmful than the iron phosphides and iron sulfides, and the toughness of the steel remains constant. So the advantage of adding manganese into steel alloys is that it sacrifices itself but protects the iron properties intact. The next comes is the stainless steel. What is stainless steel and how it is different from the normal steel which we will be using most of the time in the course. Stainless steel is also an alloy of iron with carbon as well as chromium. When the chromium content is increased to 11%, the resulting alloy becomes stainless steel. Because at this minimum level of chromium, a thin protective passive layer is formed spontaneously on a steel, which protects it from the corrosion. Nickel is also added sometimes in addition with the chromium in iron. It also protects the steel. Even in the worst situation like reducing environment where sulfuric acid is also present beside the structure, like in the bridges, if below the bridge if some sewer lines or drainage is passing which is having a huge amount of sulfuric acids or hydrochloric acids, so chromium and nickel both are added in addition to manganese as well as carbon into the iron. But addition of more and more elements increases the cost of the alloy, like the chromium and nickel are costly. So stainless steel is costlier, expensive than the normal steel which is used generally for constructions. But the stainless steel is very attractive for the architects despite of its high cost, because of its combined effect of aesthetics, durability and strength. So besides these charming features of a steel, let us come to the three challenges that we have discussed in video 1. The first challenge is the corrosion. See, corrosion is an electrochemical process which involves an anode and a cathode as well as an electrolyte. So in the case of a steel, when the favorable condition for corrosion occurs, then the ferrous ion go into solution from anodic areas and electrons are released from the anode and they go to the cathode through the electrolyte, and there they mix with the water and oxygen and form hydroxyl ions. And these hydroxyl ions at the cathode reacts with the ferrous ions from the anode and they forms ferrous oxide. And this ferrous oxide is further oxidized and form ferric oxide. And this ferric oxide is called red rust. And this red rust is the corrosion of steel. Since corrosion involves formation of rust, so the iron is in one way wasted, and hence the mechanical properties of the section is reduced. So corrosion is the first concern that a structural engineer is faced with the steel design. So there are different methods of protection from corrosion, as we have discussed, addition of nickel and chromium. Besides that, there are also methods of painting and also zinc galvanizing method and many more which we can study in the textbook. The second concern that comes in the steel design is fire resistance. See, when the fire occurs, the steel properties is not much affected. Since steel is a good conductor of heat and electricity, the thermal energy from the heat or the fire is absorbed by the steel, and after the fire is controlled, the properties of steel is regained when it gets cooled down and the temperature of a steel section comes to the ambient temperature. So not much damage occurs during the fire hazards to the steel structures, but if some damage occurs, so we can easily repair or retrofit that portion of steel. One very important challenge that comes into the steel construction is that since it is a good conductor, it carries the heat effect from one room to another room very easily. So that is very important concern with the steel construction. And in regard of concrete fails after 600 degrees Celsius, but steel construction can withstand even higher temperature, but it also fails at the higher temperature more than 1500 degrees Celsius or 1800 degrees Celsius, like that. The third challenge that comes in regard of steel construction is fatigue failure. A component or a structure which is designed to withstand certain amount of load may fracture or fail even with the application of even the lower load than the design load capacity, if the load is applied in a cyclic manner. For example, if you take this as a steel rod, thin steel rod, if I do simple bending like this several times in a cyclic manner, it will very easily fail after a certain amount of cyclic loading, isn't it? So the same thing happens in the fatigue failure. So any structure which is prone to cyclic loading, just like bridges में क्या होता है, दिन में ज़्यादा ट्रैफिक होती है, रात में ज़्यादा नहीं होती, फिर अगले दिन ज़्यादा होती है, रात को कम होती है, तो इस तरीके से एक साइक्लिक पैटर्न बन जाता है. So any structure which are prone to cyclic loading like bridges, cranes, offshore structures, because there are several tides coming in a cyclic manner, or the huge towers which are subjected to wind loading which comes in a cyclic pattern, these kinds of structure which are prone to cyclic loading have been observed that they fail under fatigue even below the design load capacity, because cyclic loading develops stress concentration at different portions in the steel sections. All these three different challenges are very detailed topic that is studied in higher courses, so we leave it here only, and hope you must have got it and you can study it from the textbook in more detail. So we will meet in the next class where we will discuss general mechanical properties of steels, different kinds of steel sections, and a stress strain diagram of steel. So stay tuned, we will meet in the next class very soon. Thank you.